To begin our lab, we prepare cuvettes for the spectrophotometer. We prepare one with a stalk, one with a blank consisting of half ammonia and half water, and then 3 cuvettes with the respective serial dilutions.
We move to the spec room and open up our scan and simple read programs. We begin with scan to read across all wavelengths from 280 to 1000.
We will clean each cuvette with a Chem wipe before placing it in the spectrophotometer to make sure no smudges interfere with our readings. We scan our blanks to clear out the system, similar to how we would tear a scale before measuring something. We remove the blank and place in the cuvette of stock solution. We read this across all wavelengths to find the one in which the majority of atoms of this specific solution will absorb energy from photons the most, or the lambda max.
Lambda max, which refers to the wavelength in the absorption spectrum that has the maximum absorption. It acts as a single quantitative parameter to compare the absorption range of different molecules.
We find this to be 605.3 nanometers.
We move to simple reads and adjust the lambda max as 605.3 so it will read the absorption at that wavelength. We begin reading the absorption by placing the blank in the spectrophotometer and hitting 0 to the base absorption as close to 0 as possible so it won't alter the absorption. We then place the stock cuvette in and read the absorption. We repeat this process of alternating the blank and dilutions for our 3 serial dilutions to find their absorption.
The Beer-Lambert law is A equals ELC. It states that absorption, A, equals E, molar absorptivity, times L, path length, times C, concentration. Absorption is how much the sample will absorb the energy from the photons of light that passes through the substance. Molar extinction, or the Greek letter epsilon, is a measure of how well a chemical species will absorb a wavelength of lights. Path length is the length in centimeters of the path that the light traveled through in the spectrophotometer. This is typically a constant amount. Concentration, or molarity, refers to the amount of solute present in the concentration and can be found by dividing the moles of solute by the volume of the solution. The Beer-Lambert law states that the quantity of light absorbed by a substance dissolved in a fully transmitting solvent is directly proportional to the concentration of the substance and the path length of the light through the solution.
We clean our areas by throwing away all used Chem wipes in the trash and dump the solutions in the cuvette down the sink before cleaning them and returning them to their designated area.
We record the concentration and absorption of all the solutions and transfer our data to a graph to help show the directly proportional relationship between concentration and absorption.